have you ever wondered what causes the ground beneath us to shake violently during an earthquake? Earthquakes, a phenomenon that has intrigued and terrified humanity for centuries, are far more than a simple shake of the ground. They are a testament to the dynamic nature of our planet, a stark reminder of the immense forces at work beneath our feet. Many of us grew up with stories of the earth splitting open, swallowing whole cities, or the myth that California will one day fall into the sea. While these stories make for interesting conversation, they are not quite the reality of earthquakes. The truth lies not in the earth opening up, but in the movement of colossal tectonic plates beneath the earth's surface. Imagine for a moment the earth as a giant jigsaw puzzle. This puzzle is made up of numerous pieces known as tectonic plates. These plates are constantly moving, albeit at a pace slower than a snail's crawl. But even at such a slow pace, the forces they generate are immense. When these plates move past each other, they don't always do so smoothly. Sometimes they get stuck. And when the force of their movement finally overcomes the friction holding them in place, it's released as energy that travels through the earth. You feel this energy release as an earthquake. From the rolling hills of San Francisco to the towering Himalayas, every mountain, every valley, every ocean trench is a testament to the ceaseless movement of these tectonic plates. They shape our world, creating breathtaking landscapes and occasionally unleashing disasters. So, the next time you feel the ground shake beneath your feet, remember, it's not the earth opening up to swallow you whole. It's not California preparing to take a dip in the Pacific. It's the very planet you're standing on, alive and in motion. So the shaking ground during an earthquake, that's the result of the Earth's tectonic plates in motion. Beneath the Earth's surface, massive slabs of solid rock known as tectonic plates are constantly moving. Imagine the crust of the Earth as a giant jigsaw puzzle, composed of numerous pieces, each one a tectonic plate. These plates are not static but are constantly in motion, albeit at a pace slower than a snail's speed, typically a few centimeters per year. These movements are driven by the intense heat deep within the Earth's core, which causes molten rock in the mantle layer to circulate in convection currents. Now, picture these tectonic plates floating, not on water, but on a semi-fluid layer of the Earth's mantle, known as the asthenosphere. This layer is not completely liquid nor completely solid, but has properties of both. It's this semi-fluid state that allows the tectonic plates to move around, albeit very slowly. The Earth's crust is divided into several of these large and small tectonic plates. The 7 major ones are the African, Antarctic, Eurasian, North American, South American, India-Australian, and the Pacific plates. There are also many smaller plates such as the Juan de Fuca plate off the western coast of North America and the Philippine Sea plate near Asia. These plates don't move smoothly past each other. They're rough and stick together, creating stress. When the stress becomes too great, the rock slabs break or slip along the fault lines. This sudden release of energy causes the seismic waves that make the ground shake, leading to what we know as an earthquake. In essence, the motion of these tectonic plates is a colossal game of push and pull, exerting massive forces against each other. When these forces are ultimately released, the energy can be cataclysmic, resulting in the ground-shaking phenomenon we call an earthquake. These tectonic plates are the key players in the formation of earthquakes. The silent yet constantly moving actors beneath our feet, shaping the Earth's landscape and occasionally reminding us of their presence through the powerful natural event of an earthquake. Now, let's dive deeper into how an earthquake is born. The genesis of an earthquake is a tale of stress, tension, and ultimately release. It all begins beneath the Earth's surface, where enormous tectonic plates, the Earth's building blocks, jostle for space. These plates, some spanning thousands of miles, are constantly moving, albeit at a pace slower than a snail's crawl. As they move, they interact at their boundaries, where they either grind past each other, collide head-on, or pull apart. It's along these boundaries that the seeds of an earthquake are sown. These interactions create stress, a silent, invisible force that gradually accumulates over time. This stress builds and builds, much like the pressure in a pressure cooker seeking an outlet. But the Earth's crust, much like the lid of that pressure cooker, keeps this stress contained, that is, until it can't. When the stress surpasses the strength of the rocks, it results in a sudden release, a violent rupture along a fault line. This moment, this release, is the birth of an earthquake. It's akin to snapping a rubber band that's been stretched too far. The energy stored as potential in the stress-loaded rocks is suddenly converted into kinetic energy, which travels outwards in the form of seismic waves. These waves, rippling through the Earth's crust, are what cause the ground to shake, rattling our world above. These seismic waves, much like ripples on a pond, spread out from the epicenter, the point on the Earth's surface directly above the earthquake's birthplace. They race through the Earth, shaking and trembling as they go, causing the phenomenon we know as an earthquake. But remember, this process isn't a one-time event. The Earth's tectonic plates continue to move and interact. Stress continues to accumulate, and inevitably, it will find another release. In simple terms, an earthquake is nothing but the Earth's way of releasing pent-up stress. The largest earthquake ever recorded in human history was a 9.5 magnitude quake in Chile in 1960. This seismic event, known as the Great Chilean Earthquake or the 1960 Valdivia earthquake, is a significant chapter in our understanding of Earth's dynamic nature. The quake was a result of the Nazca Plate subducting beneath the South American plate, a process that had been ongoing for millions of years. The stress accumulated over centuries was released in a matter of minutes, shaking the ground violently and changing the landscape forever. The city of Valdivia was near the epicenter, and the damage was catastrophic. Buildings collapsed, roads were torn apart, and sadly, thousands of lives were lost. The earthquake also triggered a series of tsunamis that reached as far as Hawaii, Japan, and the Philippines, causing even more destruction. But what does the magnitude of 9.5 really mean? Well, the magnitude of an earthquake is a measure of the energy released during the event. To give you a perspective, a 9.5 magnitude earthquake releases an energy equivalent to approximately 178,000 Nagasaki atomic bombs. It's a mind-boggling amount of energy, and it gives you an idea of the immense forces that are constantly at play beneath the Earth's surface. The Great Chilean Earthquake also provided valuable data for scientists. It confirmed the theory of plate tectonics, a fundamental concept in geology, and it led to the development of the seismic hazard assessment, which helps us predict and prepare for future earthquakes. In the aftermath of the quake, Chile and the global community came together to rebuild and recover. It was a testament to human resilience and our ability to adapt in the face of adversity. This historic event serves as a stark reminder of the immense power that lies beneath our feet. It underscores our need to respect and understand Mother Earth as we continue to live and thrive on this dynamic planet. So, to sum up, earthquakes are a fascinating and complex natural phenomenon. Let's rewind a bit and revisit what we've learned. Earthquakes are born from the restless movements of the Earth's tectonic plates. These giant blocks of the Earth's crust are in a constant dance, sliding, colliding, pulling apart, and grinding against each other. This movement, though slow and gradual, builds up tremendous amounts of stress over time. When the stress becomes too great, the Earth releases it in a sudden, violent burst, causing the ground to shake. That's an earthquake. The point deep within the Earth where this energy release first occurs is known as the earthquake's focus, while the point directly above it on the Earth's surface is the epicenter. Now, let's not forget about the Richter scale, our key tool for measuring the magnitude. of an earthquake. Named after Charles F. Richter, this logarithmic scale allows us to quantify the energy released during an earthquake, helping us understand its potential for damage. The largest earthquake ever recorded was the Great Chilean Earthquake in 1960, reaching an astonishing 9.5 on the Richter scale. Its effects were felt as far away as Hawaii and Japan, demonstrating the far-reaching impact of these powerful natural events. Understanding earthquakes is not just about satisfying our scientific curiosity. It's also about safeguarding our future. By studying earthquakes, we can better predict where and when they might occur, potentially saving countless lives and reducing the damage to our cities and infrastructure. In conclusion, earthquakes are an integral part of our planet's dynamic nature. They remind us of the tremendous forces at work beneath our feet, shaping and reshaping our world in ways we can't always see. They are a testament to the Earth's ceaseless evolution, a spectacle of nature's power and complexity. Next time the Earth shakes, remember it's just the Earth's tectonic plates doing their thing,